Okay, man.
Right, that's right.
Even though that's another chapter, I'll answer it right now. If an ionic compound called a salt, which is made of a positive ion and a negative ion, right? If, and held together by ionic bonds, if that is put into water, that chart there is the next chapter. If we find out it's soluble in water, water has the ability to do what to those ions? Pull them apart, and now you have ions floating around by themselves, like sodium chloride. But the ability of water to pull these ions apart is greater than their ability to stay together. But some of those things are called insoluble. So their ability to keep themselves together, plus minus, if it's greater than the water's ability to pull them apart, then they're insoluble. Well, that's an excellent question.
The other one.
Oh.
Oh, sorry.
Two.
Yeah, the other one was.
Two good questions.
When people speak of like cyanide poison, is that cyanide combined with something?
Okay,
or just
good.
pure cyanide?
Excellent question. When I was younger, I did not understand this stuff. It's actually sodium cyanide. And just like when they say, I'm going to put chlorine in my pool, really? You're going to put a yellowish-green poisonous gas that can kill you? No. What they do is they put a chemical in there that releases chloride ions. And that's when they say, I'm putting chlorine in there. People used to say, eat bananas, it has a lot of potassium in it. Is there a real soft, silvery, soft metal that reacts violently with water in there? And I never saw one in a banana. So what's in there? It's the potassium ions. Maybe it's potassium whatever. I don't know. I don't know which ion is in bananas, but because it's watery, it's going to have potassium ions and something else.
Well,
Yes.
So to build on what Clay asked,
Say it again?
to build on what Clay asked,
Okay.
will you ever have a situation where you just run into one of these ions by itself, or will it always move on?
Okay, now, if it's soluble in water, you could say the ion is by itself, but it's floating around with other ions. Now, have some scientists tried to trap a single ion? It could. You could get it to the point where there's one ion in the whole beaker. I don't know why you want to do that, but if somebody had some experiment, you could say, let me pull out this ion, let's pull out this one. They could try to do that. They could, because ions have charges, you can also make them go, you can say, hey, if you're a negative ion, what if I put a positive field here? They go this way. And maybe I could do that. I could pull the ions out with another charge.
But there's never like a time where you would just run into a block of...
Of ions?
Yeah.
Actually, salt, table salt. How many NaCl's are in table salt? None.
Oh,
They're all sodium ions next to chloride ions. Sodium ion, chloride ion. See that? A grain of salt has no NaCl in it. It has a million, 100 million billion NAs and 100 million billion Cls in a pattern. It has to be like a cubic. Excellent. These are great questions. Now, let's move on. What we're going to do is we're going to start the nomenclature part. Now, even though I'm using the same handout sheet as I did before in the 10th grade, your goal, I said this year, your goal is to fill in the gaps. Fill in the gaps and say, I'm going to be really good at this. If I go to college next year and I have somebody in my class and I say, how did you know that? You'll be able to teach it to them. So that's what you want to be at. Be able to teach this to somebody else. Let's take a look at type 1. All right. I was never taught, in school, that you could find a pattern to naming compounds. I did not know that there was a pattern. So if you'll let me teach you this pattern, and maybe you remember it from 10th grade, maybe you don't, okay? Don't go to college and tell the professor, is that type 4 or type 5? I made that up. I made it up, okay? Type 1. Let's do type 1. If you have a compound as type 1, first of all, what kind of compounds are we naming right now?
Inorganic.
That means we're not doing, we have in the second semester, we do organic. That's carbon chemistry. You get that? So we're not trying to name carbon, hydrogen compounds, or we'll do that later. But these are inorganic chemistry. When you go to college, they make you take, if you're a science major, you'll take 2 semesters of inorganic chemistry. Then guess what? 2 semesters of organic. I am not here. When I teach organic in the second semester, I'm not here to teach you 2 semesters worth of college organic. We just do the foundations of organic. We build models and figure out how to name them like that. So anyway, let's start here. These are inorganic nomenclature. Nomenclature means the naming system, right? Nome means name. All right, type 1. First of all, your binary. What's that mean?
2.
2 what?
Elements.
2 elements. There's one right there. See that?
That's
a
binary.
So your binary, your ionic, what does that mean? Let's take a look. Binary means 2 elements. Ionic means you have a metal who lost electrons and became an ion, and a what? Non-metal that gained negative electrons and became negative. And so what we're looking at is something like this. It might go like this. NaCl fits the bill. I'm a sodium ion, you're a chloride ion. Here's another one. BaCl2. In this case, this ion is not +1, but it's +2 charged, and the chlorine's -1, and the other chlorine's -1. That's my visualization of that. Everybody see that? So anyway, if you are binary, and you're ionic, and one more, if you're one of the always metals. Okay, so which one's the always metals? See if you remember that from 10th grade. Well, take a look up there. Where's group 1A? Everybody see group 1A?
Is it the lithium group?
Hydrogen, lithium,
It is.
sodium.
Okay, now, hydrogen is, I like this periodic table because see how they separate hydrogen? Hydrogen is really its own little group in a way. Can you make hydrogen act like a metal? You can under high pressure situations. They think some planets have enough gravity to make hydrogen act like a metal. But hydrogen can also act like a non-metal. It can be +1 or -1. So I like hydrogen being in its own little group. So you're right. Starting with lithium, these are the 1As, right? Everybody got it? That means every time they form a compound, every time, they are always +1. Always. Now, who else is always? What does it say there? You guys should have this out. You should have this handout out, that's for sure.
Group 2A.
So everybody go find this, okay? 2A, they will always, in a compound, they will always lose 2 electrons and become +2. And there aren't that many alwayses. And there's 3 more things, right? So these are +1, these are +2, and then we have silver, zinc, aluminum, little invisible stair step, +1, +2, +3. Now the reason I tell you that is that in the history of chemistry, those metals always form that charge, always. And therefore, you don't have to tell me, which sodium chloride did you mean? Sodium 1 chloride? No, you don't have to tell me that. There's only one kind of sodium chloride. Look again. There's only one kind of sodium chloride. Is there only one kind of iron chloride? No. Iron's not an always metal, is it? But if it's an always metal, you never have to worry about using Roman numerals, do you? You'll never hear calcium 2 chloride. You'll never hear that. It's an always metal. Is this coming back to you a little bit? Okay, let's go back. Now, because it's a binary compound, it always ends in what? IDE. That's why it was bad to name those polyatomic ions IDE, wasn't it? And so this is called the sodium ion. What is this called if it's an ion?
Chloride.
Chloride ion. The element's chlorine. As an ion, it's a chloride ion. Everybody get that? So we call it sodium chloride. Oh man, I think I got this. Never use a Roman numeral in the type 1. Now, what about this? And of the 5 types I'm going to teach you, of the 5 types, only one do you look at the subscript to name it. Do not get fooled and say, sodium 2, no. What's this called?
Guys,
Sodium.
oxide.
I'm not even going to look at subscripts. I'll tell you when to look at subscripts.
Sodium oxide.
What about sodium 1? No. Do not look at the subscripts in type 1. What's this called? Sodium.
Chloride.
What's this one?
Chloride.
All right, what's this one?
Aluminum oxide.
See? Don't get fooled. Are these all binary?
Yes.
Is it metal? Is it ionic?
Yes.
Metal, non-metal, right? Is it an always metal?
Yeah.
How long does it take you to learn the always metals? Look right there. I'll give you a periodic table. Are you okay with that?
Yeah.
All right, let's go on. All compounds have a net charge of zero. All ionic compounds have subscripts that are reduced to the lowest whole number ratio. So if it's an ionic compound, I'll tell you about an exception later. It will not be this. It will not be this. You will never see that combination in an ionic compound, unless I show you the exception, okay? Because ionic compounds are reduced. See that? Now, I'll tell you what that really means, and I hope you understand this. If I have a piece of table salt in my hand, why don't I say Na 100 billion trillion, Cl 100 billion trillion? And if it's a bigger piece of salt, they don't do that, do they? Because in an ionic compound, there's no such thing as an NaCl. But what is the lowest ratio of the elements in table salt? What's the lowest whole number ratio of Na ions to Cl ions? It's a 1-to-1. So an ionic compound is not like later in the year we'll have ball and stick model. You'll put a hydrogen here and you put a hydrogen here. Ball and stick models are for covalent bonds. You guys probably did this in your biology.
Oh, yeah.
This is for covalent bonds. You're not going to use ball and stick here because it's like this. It's not ball and stick. They're not sharing electrons at all. Everybody got that? Okay, let's go to type 2. Type 2, guess what? Binary. I already got that down. Ionic. I got that down. And what's the other thing? Not one of the always metals. So, if you are going to use this, or silver, zinc, aluminum, then that's type 1, isn't it? But any other metal, osmium and oxygen, I have to use a Roman numeral. If you're not always metal, God made it so that some of these metals always do the same thing when form a compound, and some of them don't. You'll learn, and I want you to memorize this. You're big boys and girls now. Iron can only do 2 things that we know of. Run out of batteries. It can be +2 or +3. All right? We use iron all the time, so you might as well learn that one now. And what about copper?
+1, +2.
See that? It's copper +1, +2, iron +2, +3. And that's the ones that you should know by now. But let's take a look at this. And same rules if it's binary ends in IDE. So let's take a look. Let's do this right here. Fe2O3 and FeO. I'm going to do that.
Didn't you just say copper was an always metal?
What now?
Didn't you just say copper was an always metal?
No, not copper. What I said was group 1, group 2, silver, zinc, aluminum. Silver, zinc, aluminum. +1, +2, +3. Okay? Now, look at these two right here. What would you call these if they were type 1? If they were type 1, how would you name them?
Iron oxide.
Okay, let's do that right now. Iron oxide. Iron oxide. So it's almost the same, but that's confusing. Hey, go back to the storeroom and get me some iron oxide. Which one? Which one? I didn't have. There's only one kind of sodium chloride back there. There's no other way to make sodium chloride, but there's 2 ways to make iron oxide, aren't there? So we have to do one more little trick. Ready? We have to put a Roman numeral here, and the Roman numeral is always the charge on the metal. So let's take a look. Ready? Except for peroxide. Oxygen is always what charge in a compound, except for peroxide. What is oxygen? Let's do the nominals. Ready? For the most part, in general, these don't form bonds. These are -1, -2, -3. Yes? Remember that? Okay, so in a compound, except for peroxide, oxygen is what?
-2.
Each oxygen is -2, but you have how many of them?
3.
That's -6. All compounds have to be 0. 2 times what equals +6? 3. Now, what is the charge on each metal?
+3.
So I put a what? I put a Roman numeral 3 right there. This is iron 3. Now, I know what you might be thinking. Well, there's a 2 there. No, don't look at subscripts. I'll tell you when to look at subscripts and name it. Get that? We don't look at subscripts now. I only use this to tell me to figure that out, that was +3, right? So we do a little extra work to name these compounds. Take a look here. Oxygen's -2. The whole thing has to be 0, so you must be +2. What Roman numeral goes here? 2. This is iron 2 oxide. What's this one? Iron 3 oxide. Okay, let's try some. All right. Let's go reverse. All right, let's go with Rolonsky. Which one do you want to do? You want to give me the formula for copper 1 nitride or copper 2?
I'll do the first one.
All right, what do you got?
C.
I'll give you a clue. I'm going to put a little +1 right there because it's copper 1.
C.
Nitride.
U, and then the Cu is subscript of 3.
Cu is +1. What's this one?
And nitrogen
And what's that?
-3.
Yes. Okay, now what?
So subscript of C is 3.
Like that? Very good. Very good. All right, you want to try it, Clay?
Sure.
How you do the next one?
Well, the copper now has a charge of +2, and the nitrogen still has -3. So Cu is going to be 3, nitrogen is going to be 2.
What is it?
3, 2.
Are you okay with that? Okay, so this is, I know what you want to do. You want to look at those subscripts and name it. No. This is copper what? Copper's charge is +2. Copper 2 nitride, copper 1 nitride. Are you okay with that? Now, when I was doing 10th grade, I would have skipped over this and come back to it later. But now, again, you can handle this. And I think we got this down, don't we? Yes.
So, looking up at the periodic table, it looks like nitrogen can have all those different charges, so why don't you put the
Yeah,
number?
all right. So, okay. Excellent question. For right now, unless you have some reason to think there's something weird going on, nitrogen is going to be -3 in a compound, okay? Now, later, if we find out, oh, the only way that compound would be formed is nitrogen would have to be something weird, wouldn't it? And we'll do that later. But for right now, it's -3. That's a great question. And there, in another chapter, what we'll do is we'll do something like this. I'll say NO3 -1. I'll say, what is the charge on nitrogen in the polyatomic ion nitrate? And if you don't want to listen to this right now, you don't have to. But each oxygen is what? Each oxygen is what?
3.
No,
-2.
-2. And I have how many of them? That's -6. -6 plus something has to equal, not 0 here, but what? -1, so we got, whoa. In the polyatomic ion nitrate, nitrogen actually takes on a 5, +5. But for right now, if I'm just writing compounds, and unless there's something weird, you're going to say nitrogen is -3. Nitride is -3. But it's a great observation you had, and it'll come into play at some time. Now let's go to the next part. The next part is there was a system that they used before they started using Roman numerals in chemistry. And it was the IC-US system. And that's a stupid name. But the IC-US system, some people call it the Latin name. But the IC-US system, at one time, chemists thought, whoa, look at this iron. That iron can't be +2. I thought iron had to be +2. And somebody discovers, no, it's +3. Well, and then they thought every metal could be one or another. At one time, they thought metals only had 2 things they could do. And so the IC-US system worked for a really long time. So let's try it. Let's go with this right here, okay? Let's go with CU, let's do CuO and Cu2O. Okay. All right, ready? Forget the Ichnos. What would you name this using they call it the stock naming system, also the Roman numeral system? How do you call this? How do you name this? Well, you're not an always metal, so I gotta do a little extra work. What's this guy?
Copper 2 oxide.
Okay, so copper 2 oxide. Okay, I like that. And what about this guy?
Copper 1 oxide.
There you go. Each copper is +1. Okay, now we got that down, don't we? Now, the old system would have been called the Ichnos, or the Latin words, the Latin name. Okay, here's what my memory trick is. I can't believe I have people coming back from college and said they remember the Ichnos. They remember the big icky monster. And so copper can be 2 or 1. Which one's bigger? Which is the big icky monster? 1 or 2?
2.
Okay, how about this? Which one's a big icky monster for iron? 2 or 3? 3. Okay, so watch. This guy is going to be the icky monster. Instead of saying copper, they use the Latin word for copper, which is what? No, cuprum. Cuprum. And we use the word cuprum. Watch now. And you said he was the big what? Big icky monster, cupric oxide. All right, let's try it again now. This right here has the name copper 2 oxide. This one's copper 1 oxide. What's another name for copper 2 oxide? Cupric. And notice you don't use Roman numerals if you use the Latin form, do you? Cupric oxide. I wouldn't teach this to you if I thought it was just, hey, the new naming system is much better, so why don't we just drop this? The problem is they won't drop it. I don't know why. Right now, when I have to order chemicals, let's say for next year or this year, I look in a catalog and I won't even see the word copper 1 oxide written. I'll see cupric or cuprous. So if I don't know what cupric is, I can't even tell you which one it is. So you do have to learn both these. What's this one called? Cuprous
What if it
oxide.
has more than, like, what if-
Okay, that's the problem. See, that was a problem. It was good for most metals. Most metals only had 2 forms. Take a look up here, and in your book, you'll actually see, I think it's your handout sheet too. The Latin word for copper is cuprum, and so it's cupric or cuprous. What's the Latin word for iron?
Ferrum.
Ferrum, so it's ferric and ferrous, isn't it? Guess what the Latin word for this one is?
Manganese.
Manganese. So it's manganic or manganous. And in 10th grade, I thought it was a pretty funny joke. I had a ship, and the ship had Titan. I mean, it had this one with a plus. What did it say? Plus what? 4? Is that the biggest number up there? And so, what would titanium plus 4 ion be called?
Titanic acid.
Titanic, yeah. Okay. Anyway, and so I had a Titanic, and then what about? How about this one? This is weird to me because even though it would be Nicklick and Nicholas, I never see Nicklick written. I just think chemists just say, no, I'm not saying it. I'm not saying it. I'm not saying Nicklick. And so nickel always, I see the Roman numeral with nickel all the time. It's just like when astronomers at one time, when I was learning astronomy, it was Uranus. And then I remember in biology class, we did on earthworms, I had to learn all the parts of earthworm, and there was a hole in the back of the earthworm. Oh, this is on tape. Okay, that's right. There's a hole in the back of the earthworm, and I had to learn this new name. What was it? What's a hole where the poop comes out?
But
Anus. It's anus. Okay? And then I started seeing people on TV, and here's these astronomers on TV, and they're supposed to say the word Uranus. But you know what? Uranus. Well, you're calling it Uranus. I think, honestly, they didn't want to say Uranus and not laugh.
Cowards.
I don't. So anyway, I'm just making it up, but I'm telling you, it was always Uranus. There's Uranus, and all of a sudden everybody said Uranus. And I just think, and I don't think I've ever seen Niklik either. I just don't think they want to say. All right, here's another one. Let's see.
What's zinc? Zinkic?
I don't. I've never seen the Latin for that. So it's probably just Roman numerals. So, all right. Well, let's. Oh, I know another one. Lead. Lead and tin. Lead and tin. Here's tin, and here is lead. See these two? These two are. See how they're right underneath each other in the periodic table? These are +2 and +4. +2, +4. So the stannum means tin, and so stannic and stannus. And in here, plumbum, there's plumbic and plumbus. Anyway, I can do that for you temporarily. I can actually, on the test, I can probably give you the Latin names. Does that help you out a little bit?
That'd be great.
Okay, I'll do that. All right, now, believe it or not, that's type 1 and 2. So now let's go to the next one. I honestly think, here's my opinion. I think type 3 is easier than some of the type 2. Yes?
So for when you got things like titanium that have 3 possible charges, and you're using
All right.
that Latin system.
That's right. That's what he asked.
I missed that.
Okay, but you know what? You're right. They figured out quickly that we got to drop this, and then they came up with this idea of the Roman numerals, and that's what you're going to see in your modern chemistry books. You're going to see the Roman numeral. That's called the stock naming system. But now, I would have to. This right here, I have seen manganus and manganic. I would have to look up to see. It's probably the 2 most frequently found in nature. Now, I don't happen to memorize that. I'd have to look up which one is the most commonly found in nature, because manganese has 4 of them, right? But I know I've seen manganus and manganic. I'd have to look them up. So I'll bet it's on here somewhere on one of my handout sheets. Let's do type 3. Now, type 3, watch now, it's ternary. What's that mean? It's not binary. 3 or more. 3 or more elements. You get that?
Yeah.
Okay, so let's write one out. NaNO3. Now, I have some good news, just like I said in 10th grade. I have some good news for you. If it's not binary, good news for you. If it's not binary, it contains a what? A polyatomic ion. Good news number 2. Somebody else has already named the polyatomic ion. Good news number 3. You will never, never change the name of a polyatomic ion. Remember how we changed chlorine to chloride? You will never change the name of a polyatomic ion. Now, everything else is the same as type 1 and 2. So let's try it. This is type 3, right? And this is called what? Nitrate. Now, this is an always metal, so I don't have to worry about which sodium nitrate is it. There's only one way to make this, because there's an always metal. Now, what would you call this again? What's the name of this one? Sodium? What? It can't be that easy. It is. Now, let's get a little harder. Okay, let's get a little harder. If this had been an always metal, what would you have called that? Help me out. Iron nitrate. So, because it's not an always metal, we have to spend a little extra time. What's the charge on nitrate?
-1.
You have to know these. How many nitrates do you have?
3.
That's -3. The whole thing has to be 0.
Iron 3.
So you must be what? Iron 3 nitrate, also known as... You are correct. Ferric nitrate. What do you think?
Good.
Are we filling in gaps?
Yeah.
So you could teach this to somebody, right? Okay. Now, I do, here's something else you need to know. When is the only time that you would use a parentheses in a formula? Yes?
When there's a polyatomic
Try it again. I didn't have one here. There you go. All right, the only time you use parentheses is if there's more than one polyatomic ion. You get that? So you would never write NaNO3 with a parentheses, okay? What's the name of this? One of the most famous chemicals in the world.
Sodium hydroxide.
Okay.
Or side one.
What about this one?
Copper.
You were so fast on this one.
Hydroxide.
Really?
One hydroxide.
What? What? You had to put a Roman numeral there? Why?
Because we're using
Because it's a
stock
metal
system.
with
Sparky!
It's not an always metal, is it? So we take a little extra time. Hydroxide's -1. You must be +1. Copper 1 hydroxide, also known as cuprous hydroxide. All right. What do you think?
You can't win them all, it's fine.
Now,
Three gets a little less.
Now it's time to do the one. If I was in 10th grade, I would have waited till almost the last day to show you the exception. Let's do the exception to the rule. And the two biggest exceptions you'll ever run across in chemistry are the mercury 1 ion. What is that one? It's a polyatomic ion. Hc2 what? Okay, there's that. And the other one is a peroxide. What's peroxide? O2 what? Okay, now, let's make a compound of this. I'm going to make a compound out of this and sulfur. Okay, so sulfur is -2, is that correct? Is sulfur -2? Okay, so what are you going to call this compound? Be careful. What are you going to call HD2S? Be careful. This is -2. This has to be +2, but there are two of them. So each one is what? What is each mercury?
Mercury.
Mercury 2 sulfide.
One sulfide.
Each mercury is what?
Oh, 1.
Mercury 1 sulfide. Also known as mercurous sulfide. Now, I want you, if you have a piece of paper out, I want you to write out the formula for mercury 2 sulfide. Write out the formula for mercury 2 sulfide. That's fast. Raise your hand if you don't say the answer. Raise your hand if you know how to do this. Mercury 2 sulfide. Okay. All right. Now you guys didn't raise your hand, so you're gonna help me out, okay? Mercury 2, Jeff. Mercury 2 is not an exception. Mercury 1 is the exception. Mercury 2, watch this now. It's like iron 2. See that? And what are you gonna put next to it? Sulfur. What's sulfur in a compound? Look up there. The fluorine and chlorine, the halogens are -1. What's the sulfur column? These are -1.
It's -2.
-2, okay. So guess what? We're done. HCS. See, HCS, it's just like iron 2 sulfide, right? Iron, see, so the iron 2, mercury 2 is not an exception. That's easy. It's mercury 1 that you have to write Hc2 + 2 and then do that. And I'm going to show you something. Watch right here. Mercury 1 chloride. Watch. Hc2 + 2. Chlorine is a -1. What are you going to do about that? No.
Oh, you have to times it. You have
Okay,
to
now,
do-
guess what? That's one of the only times that I broke my rule. Ionic compounds are always reduced to the lowest whole number right here, right? You know there's something weird going on because this ionic compound has not been reduced, has it? That's an exception. Let's do another one. Do sodium oxide and sodium peroxide.
It would be,
Okay, yeah. What I'm saying is, ionic compounds, metal, nonmetals, you'll never see 4 and 2 or 3 and 6. It's always reduced to the lowest whole number ratio, except in this an exception, isn't it? The mercury 1 ion is an exception, and that breaks the rule of that.
and also in mercury 1 peroxide, right?
Well, we can do that too. Let's do sodium oxide and sodium peroxide. Let's do that. Sodium oxide, what do you think? Sodium oxide. Sodium oxide. Are we done?
Nope.
No, that won't work. Now does it work? Now does it work? That's sodium oxide. Now do sodium peroxide. Peroxide, what's that? That's a polyatomic ion, isn't it? Don't you have to memorize that one? O2 minus 2. Now let's put sodium in there. Let's see, I'm +1 and you're what? Uh-oh. Ooh. Ooh. That's the other time. So that's the only 2 times that I know of that an ionic compound is not reduced to the lowest whole number ratios. So if I were to see something weird like that, what if I saw something like this? K2O2. Oh, metal, non-metal, ionic. Something's not right there. Something's not right. Here's what you think. You think, well, this oxygen might be -2. And if this is -2 and there's 2 of them, that's -4. And no, something's not right.
Must
But
be
if this is
peroxide.
O2 minus 2, the whole thing's -2, then it will work, won't it?
Wait, whenever you see O2, is it minus?
No, what I'm saying is, if you see a metal and non-metal, an ionic compound, and it's not reduced to the lowest whole number ratio, it's probably either a peroxide or it's mercury 1, isn't it? And again, I can spend a little more time with you as seniors because you had all this other stuff. All right, now, here's what I'd like you to do. Here's what I'd like you to do.
Don't we have advisory?
What now?
Don't we have advisory?
I can't hear.
One is it?
Don't we have advisory?
Yes, but can I tell you one thing? When you come to class tomorrow, you said, I will know 25 polyatomic ions. I know their name and their charge, okay? So that's your goal. By Friday, remember, Friday, you were supposed to learn 15 by Monday? And we went over yesterday?
15.
Went over everything?
I'll let you down.
All right, go to advisor. Okay, you can do it. You can